Good morning, good afternoon, everyone, and welcome to this FGas policy session. We've been having a few technical problems, so we're still waiting for one of our speakers, but we're going to crack on now so we don't waste any more time. My name is Claire Perry. I am the Climate Campaign Leader at the Environmental Investigation Agency. We have just under an hour to talk about FGas policy, and we have 3 presentations for you this afternoon. After this quick introduction from me, you will hear from Asbjørn von Sild. Asbjørn is a convener of the working group behind the IEC 60335-240 Edition 7 safety standard, which is the forthcoming safety standard for air conditioning, heat pumps and dehumidifiers. So you'll hear the latest updates on that important development. After Asbjørn, we'll hear from Fionnuala Walravens, EIA UK's senior climate campaigner, who will share our views on the current review of the EU FGas regulation. And then finally, hopefully Christina Starr, EIA US's senior policy analyst, will join us and be able to tell you about all the recent changes to US policy, including the AIM Act. We plan to go straight through all the presentations, but have time for questions at the end. So please use the Q&A function at any point during the presentations, and we will try and respond at the end. I'm just going to share my screen as I have a couple of slides for you. So hopefully you can see these slides. This is the plan for the webinar. I just wanted to say, first of all, a few words about EIA. We're a non-governmental organisation, non-profit, that was set up in 1984. We investigate and campaign against environmental crime and abuse, and we have 4 programs of work: climate, forests, oceans and wildlife. Our climate campaign started in the 1990s when we began investigating the illegal trade in CFCs, and we've been one of the few active NGOs at the Montreal Protocol ever since. So, for example, we've been closely involved in the negotiations that culminated in the Kigali Amendment. I just wanted to share a slide to sort of set the scene for the other presentations. You may have seen recently a paper published in the Nature Climate Change Journal, which is entitled "Achieving Paris Climate Goals Calls for Increasing Ambition of the Kigali Amendment." And essentially what these graphs show is that the current Kigali Amendment scenario ambition is not consistent with a 1.5 degree Paris Agreement target. And you can see on the right-hand side, the bottom blue bar is the estimate of emissions in 2050 under the Kigali Amendment. And this is based on the gains model of the International Institute for Applied Systems Analysis, IASA. And the orange vertical box indicates the estimated range of HFC emissions consistent with a 1.5 degree target. So they've modeled various different scenarios, 3 of which can bring emissions below that range. So the point I'm trying to make here is that there is still a lot more to be done globally to address HFC emissions. The Kigali Amendment will need to be adjusted, and the impact of removing barriers to the uptake of natural refrigerants, such as safety standards, and having ambitious legislation in the US and in the EU to open up the market to climate-friendly alternatives to HFCs. The impact of that really cannot be understated. So I hope this webinar will give you a useful update on these very important issues, and thank you again for participating. I am going to stop sharing my screen now and hand over to Asbjørn.
Thank you. So you should be able to see my screen by now, and with a little bit of video too. Okay, I'm going to give you an introduction to the new IEC 6335-2-40 edition 7, and my focus is going to be on what is happening for hydrocarbons. So, just a brief introduction. -2-40 is the safety standard for air conditioners, heat pumps, and dehumidifiers. It's not the only possible safety standard that you could use, but it is the one most commonly used for factory-produced units, which is the main part of the market. In the coming version, edition 7, we are going to enable broader use of flammable refrigerants. It's all the way from A2Ls to A3s, but most importantly, A3s includes propane, and propane is gaining a lot of attention at the moment. It's currently out for final vote with publication in June. And I'll show a little bit about the timeline later. But some examples of, or an example of where we see a huge increase with the new edition. In the old edition for propane, with in this case, I believe it's a wall-mounted system. We used to have a limit in, let's say, a 20 square meter living room of a little bit more than 300 grams of refrigerant. But frankly, for an efficient split air conditioner, you probably need something more like 450-500 grams of refrigerant. And with the new standard, we are going to enable that. You could say that the old standard actually officially allowed up to 1 kilogram, but the room size restrictions were way too restrictive for you to use this in reality. So it was in reality prohibiting propane in large units or in large rooms, and that is being changed now. And I'm going to go a little bit into what are the technical changes that we try to take into account. But you can actually see it here on the charge limit overview. Below 150 gram, we've always had no room size restrictions. So this would be something like a very small dehumidifier, something like that. The standard system is the typical split system, and we do have systems, especially Godrej in India, are actually having their charges in this area where it's a standard system. Now with additional measures, you're going to be allowed to enter the yellow area. So another increase for indoor applications. And if you add circulation airflow, you can then also enter the green area. So in a 20 square meter room, you would enter above 800 grams. Right. So what are the mitigation measures? The first one is releasable charge. And the idea is that only if refrigerant goes into the indoor room will it actually cause a significant hazard. So if you can do something like safety valves or maybe some operational measures such as doing a pump down before you go into a specific operating mode, then you can keep your refrigerant mostly in the outdoor section of your heat pumps or air conditioning system. And the way we've done this in the standard is you have to run a specific test where we simulate a leak. And then you measure what is left in the system. For a heat pump split system, my estimate is that 80% of the refrigerant is actually outdoors. And that means those 80% doesn't need to count in your charge limitations. The next option we have is airflow. The current limits in the published version of the standard are actually based on the idea that once refrigerant leaks out of the unit, it will fall to the floor due to gravity. And on the way down to the floor, it gets diluted. And we don't want the floor to go above the concentration needed to ignite the refrigerant. But actually, if you have airflow, the refrigerant will not fall to the floor. It'll be distributed all through the room. And it doesn't take a lot of airflow to do that. So by taking airflow into account or requiring that you add airflow, then you, along with the airflow requirement, get a much larger allowance for refrigerant charge. This was developed specifically for A3 refrigerants. And you can see it's been a combination of a lot of simulations and also a lot of testing, typically with propane. Then we have enhanced tightness. And the thing is, the current standard assumes that you leak a quarter of the refrigerant charge every minute if you have a big leak. But it is very, very rare that we see this type of leaks in reality. We only see it when people have done something really bad to their system, like when you find a system with a bullet hole, then you probably have something like this. So what we did was we added additional requirements. And if you choose to use these requirements, you can then calculate with a lower or assume a lower leak rate. And assuming a lower leak rate actually automatically leads to a higher charge allowance. Because there will be more time for the refrigerant to dilute the room, you can leak more before it becomes dangerous. Yeah. So here on the right, you have a couple of airflow formulas, just to show you what type of differences you get, but probably on the edge of being unreadable. Anyway, let's keep it at an overall level. What I assume will be happening in the market is we're going to see a transition away from the high DWP HFCs. Specifically for the small air conditioners, the heat pumps and dehumidifiers, you can build them with up to almost a kilogram of propane for split systems. For outdoor air-to-water systems, there is actually already since 2004, so almost 20 years, an allowance for up to almost 5 kilograms of R290. So it's not that new that you can do big R290 units outdoors, but I do see in the market that a lot of people are exploring these options, and people or companies are bringing to market R290 air-to-water heat pumps. And if you combine these limits with charge optimization and the fact that hydrocarbons have a lower weight, then you will see a further increase in the accessible market for propane specifically. There will be some additional measures if you choose to go above the traditional charge limits. However, the systems I've looked at so far, it has not been a significant barrier. So it's not a big issue. For instance, split air conditioners do have a fan built into them. So providing airflow is not actually something that is a big issue. And I expect the result would be that most systems, most large systems can be built without A1 high DWP HFC refrigerants. And those that you cannot build without traditional high DWP HFCs are probably built on architectures that are not going to survive in the long run anyway. So might not be a big loss. By the way, just now we talked a lot about the -2-40 and almost 1 kilogram. The fact is that EN 378 in Europe allows up to 1.5 kilogram of R290 for indoor applications where you have ordinary people coming and going. It's not so suitable for factory built systems. So people normally don't use it for factory built systems. But it is there, and it is also being updated with the same type of techniques as we introduce here in -2-40. A little bit about the background process. Just to show you that this is not just a quick fix. It has actually taken a significant effort. We started back in 2015 with approval for working on this topic. We had a working group 16, that was active for 4 years. It had 50 experts from 15 countries. By the end of the working group's work, we had 500 documents in total. We met every 2 to 3 months, typically in person. Had 17 meetings, typically 2 to 3 days. Then in 2018, we merged the working group 16 with the working group that's been working on A12 refrigerants, so that we could start getting everything with flammable refrigerants together. And in 2019, we actually transformed this working group into a new working group with the responsibility to publish the next version of -240. And this new working group now had 55 experts from 17 countries, managed to get through 520 documents with a meeting every 3 to 4 weeks, at least once a month at least. In the beginning, a couple of face-to-face meetings, but due to Corona, we had web meetings around every 4 weeks. Between the web meetings, because web meetings on an international scale is you only have a few hours available where both the Japanese and the US can participate. So between these web meetings, we had a lot of ad hoc groups and ad hoc meetings. So although we had only had 30 meetings in the working group, in total we are way above 100 meetings. So what is left is the standard is now out for final vote. And that final vote will end on the 29th of April. Typically, the National Committee will have a deadline 1 to 2 weeks before, just to allow the National Secretary enough time to send in the vote of that particular country. Publication early June. I've calculated June 8th, but it depends on there can be some variation. The pass criteria, we need 2/3 of all P member countries to vote yes. And we have 27 P member countries, so we need at least 18 yes votes. We also have observer countries, O members, and no more than 1/4 of the voting O members plus voting P members are allowed to vote no. So hopefully we will pass the vote here on the 29th of April and have our publication in June. So now I'm going to tell a little bit about how to apply this in EU, because an IEC standard is not an EU standard. And the way you comply with the European safety regulation is you comply typically with a harmonized standard. And this new edition 7 will not be harmonized from day one. It probably take 2 to 3 years. But the European system also has the option of applying a risk assessment, or what they call an other specification. And that's actually what people are using today to apply the IEC 6335-2-89, the one allowing up to around 500 kilograms of propane in display cabinets. So in the same way, you can actually apply the -2-40 edition 7 from the day it's published, using the risk assessment approach. I'll tell you a little bit. Okay. I'm not going to go deeply into the how do we develop the EN version, but I'll just, before we go to the conclusion, mention that previously making the EN version of edition 6 has taken 6 years, or so it's taken 4 years. And before that, we had edition 4, and we actually gave up on making edition 5 available as an EN standard because of a lot of bureaucratic problems. However, it does look like the process is more streamlined now, and we can reuse the work that was done on the 6th edition to make an EN version of the 7th edition. So, conclusion. -2-40 edition 7 will allow larger charges for both A2L and A3 refrigerants by applying mitigation measures. Approximately 1 kilogram of R290 will be the limit indoors. Approximately 5 kilogram is the limit outdoors. This new standard, I would argue, marks a transition away from the high GWP HFCs. The development of the edition 7 has taken a long time. It's been a very thorough process. Final vote, 29th of April, fingers crossed, and publication expected in June. And in principle, you can actually apply the standard immediately using a risk assessment. And then in 2-3 years, it will be a harmonized standard. So approved by the EU Commission. Okay. Thank you very much. I'll leave the word to, well, I guess it's back to you, Claire, right?
Thank you very much, Asbjørn. That's a great summary of an incredibly important issue, and we're looking forward to a positive vote. Very important for our efforts to mitigate climate change. So I'm going to swiftly hand over now, if you could stop sharing your screen, thank you. Hand over to Fionnuala Walravens.
Hi, thanks, Claire. So I'm Fionnuala Walravens. I'm on the climate team. I work with Claire, and I'm going to talk to you today about what EIA would like to see from the FGas regulation review. Sorry, I'm not sure why it's not going through my slides. Oh, here we go. Okay, just to give you a little bit of background information, EIA has a long history of involvement in the FGas regulation. We were actually involved in the previous review, and since then we've worked to support implementation and enforcement of the regulation. We also work with a large coalition of NGOs from across Europe who work together to support further emissions reductions, and we'll be working on this review to try and get the most ambitious regulation possible. One of the ways that we try and support this regulation and the most ambition that we can get from it is to demonstrate the availability of energy efficient HFC-free cooling. We have a database of sustainable cooling at cooltechnologies.org, and we also developed a pathway to net zero cooling product list, which was a review of the most energy efficient cooling products across a range of sectors, which we developed for COP26 last year. Oh, sorry, it's very sensitive. So yes, how can, why is a more ambitious FGas regulation beneficial for your business? And I think since the regulation was last reviewed, the corporate world has really changed. There's so much more attention to environmental ambition, and climate corporate net zero goals are actually enshrined within many businesses. Most businesses already have set these goals, and if not, they would certainly be looking to set these goals very quickly. And so having an FGas regulation which can help reduce use of HFCs is actually going to help implement private sector goals. So this is really supporting you towards climate ambition. Also, since the last FGas review, we've seen a huge increase in the amount of European manufacturers producing natural refrigerant-based technologies. So again, this regulation has the opportunity to support European businesses and also put European businesses on a really good setting globally as the world also begins to phase down HFCs. And then lastly, it actually helps to level the playing field across a range of businesses. So we see how sectoral bans can reward early actors who are ambitious and try to move ahead of the others, but also it helps guide some of the less progressive companies and helps them to avoid costly mistakes. So for example, those, having a placing on the market ban helps avoid a company from investing in HFC-based technology, which could result in very expensive, either having to remove the technology before its end of life or just very high ongoing refrigerant costs. So just to give you a big picture view on what we think we need from the new FGas regulation, I think we need to be thinking about ambition. The world we live in now is very different to a decade ago. The IPCC is sending us terrifying warnings about where our climate is going. HFC reductions are cost effective. They're very fast acting. This is really the low hanging fruit that we need to be focusing on, and we need to accelerate the FGas regulation in line with the 1.5 degree scenario. And again, as mentioned, this needs to be supported through placing on the market prohibitions, through strengthening the current ones and adding new ones. We also need to move away from using these very high GWP HFCs such as 404A. We're still seeing a huge amount of this gas on the market through EIA's investigations. So it needs to be banned outright. And we also need to think about the current GWP limits that we have on existing bans. These were set quite arbitrarily at 150 GWP. And again, technology, what we can do with GWP has really changed. So these need to be revisited. We also want to see the proper promotion of HFC-free alternatives and supporting these alternatives. This could be done through the polluter pays principle, through a quota allocation fee or auction. We also need to support the service sector industry through the inclusion of natural refrigerants in certification programs. And again, trying to think about how we can close the loop and reduce HFC emissions in equipment at end of life. And really, again, the corporate world has changed so much in the last decade, and producer responsibility schemes are enshrined across a range of sectors. Again, we need to see those put into the FGas regulation. I just want to dive in a little bit into why bans are really critical to the success of the future FGas regulation. I think one thing up to date, some end users have simply relied on the ability of a drop-in blend to substitute very high GWP HFCs. But as the phase down really begins to crunch, we're not going to be seeing these kind of drop-ins available, because the reality is that refrigerants are going to get more flammable. So we need to see more ambitious placing on the market bans. Our Pathway to Net Zero review of technology highlighted a lot of different sectors where we are ready to move already, and we'd like to see these bans enshrined in the FGas regulation. As Bjorn told us, if we get this new standard already, we can start implementing it in Europe. We don't need to wait for 2 or 3 years, so we can have immediate equipment bans in single split AC. Other areas include chillers, condensing units. When it comes to transport refrigeration, our review in our Pathway to Net Zero found that the innovation was lacking here, but when we actually engaged with producers of equipment, they indicated that they were looking for policy signals through bans. So again, the bans can be used to drive innovation. And certainly a hot topic at the moment, F-gases are not just to do with cooling. They are being increasingly used in heat pumps. And whilst we need to rapidly expand our heat pump rollout to enable low carbon and renewable heating, we need to make sure that that is maximised through avoiding locking in HFC technologies. And again, there are a variety of natural refrigerant alternatives available across all sectors, all major sectors, industrial, commercial, and many domestic uses. So we need to be looking at bans in those sectors. Also, look at what we have with our existing bans. So the commercial refrigeration ban was very successful, but we don't need to have this primary circuit exemption. We can just go totally over to CO2. And the stationary refrigeration equipment ban is quite an interesting one, because it's very broad-based, but its current 2,500 GWP limit is very unambitious. And we are now in a situation where we can go so much further. We can achieve so much more. So we should be looking at lowering that threshold to 150 or lower, and removing the current low temperature exemptions. I just wanted to touch on a little bit on climate crime and how important it is that we tackle climate crime in order to keep emissions low. Climate crime can actually result in a huge amount of extra HFCs on the market, and our investigations estimated that it's equivalent to about 30 million tonnes of carbon dioxide per year on European markets due to climate crime, HFC climate crime. And to put that into context, that's almost Switzerland's annual emissions. So this is a huge figure. It also slows up the uptake of climate-friendly alternatives. And this climate crime is linked to organised crime, which is very significant for end users. They don't want to be using HFCs, which have potentially been connected to this type of crime. In terms of what we can do, we are aware of ideas to link HFCs to the EU custody single window. And this is a brilliant step forward. It's going to definitely help prevent front door smuggling, which is when an importer openly declares the HFCs at customs. So that's going to make a huge difference there. But it's not going to do much to prevent backdoor smuggling, where the HFCs are hidden in order to bring them into the EU. And that's really where we need to think about supply chain traceability. Again, this is an area where the corporate world has really changed, and supply chain due diligence is becoming enshrined in this sector. And we need to look at ways for this to be applied to HFCs. And I think my colleague Christina is going to talk a little bit about the US HFC phase down and how they will be enacting an HFC traceability scheme from 2025. So the question is, can Europe keep up? And then just one last slide, looking at, yes, we need to go low GWP, but why not HFOs? I think, this is a natural refrigerant conference, but, it's worth talking about why HFOs are not future-proof. Increasingly, people are aware of the environmental pollution that are associated with certain HFOs, particularly 1234YF. When it breaks down in the atmosphere, it gives off a chemical called TFA, which is part of the forever chemical family of PFAS. Earlier on last year, several member states have actually proposed restrictions on PFAS. These would be EU-wide, and it's certainly a signal that there may be regulations on HFCs in the future. Additionally, the Montreal Protocol experts have actually also warned that the amount of TFA coming from HFOs could be of considerable environmental relevance in the future. So it's something that there isn't going to be a huge amount of space for uptake of these chemicals. Also, looking at them from a climate point of view, although they may have a low GWP, they take a lot of energy to manufacture them. So 1 kilo of HFO can produce at least 13.5 kilos of CO2 emissions during manufacture. And then something that EIA is very aware of is what sort of issues stimulate illegal trade. And we know that HFOs are much more expensive than HFCs. And often systems containing HFOs can actually have HFCs dropped into them. So there is a high risk that HFCs could be dropped into systems which should have HFOs during servicing. And this would then stimulate illegal trade. So I just wanted to summarize. Ambitious action on HFCs is really beneficial for companies. It's essential for net zero commitments, but we must be careful about where we go to next. And it's really time to get off the chemical treadmill to avoid having future changes again. We believe that much more ambitious HFC phase down and bans and illegal trade measures can actually support businesses. But it's important that your voice is heard. It's not just about civil society, talking about the environment. We really need industry to step up and make this happen. Thank you.
Many thanks, Vin. Okay, and we'll move swiftly across the ocean to Christina Starr. Thank you very much for getting up very early, Christina, for this presentation. She's going to talk to you about the US HFC policy.
Yes, great to be here, everyone. Let me just share my screen. Okay, hopefully everyone can see this. And great. So, hi, everyone. It's great to be here, and good afternoon and evening to everyone else around the world. So I'm going to give you an overview on US HFC policies and the real opportunities we have to restore US climate leadership under new laws passed in the waning days of the Trump administration, the American Innovation and Manufacturing Act. And as you heard in our last presentations as well, the real key here is going to be our ability to accelerate HFC reductions. And this law really is a game changer in that way. In the past, it has been a challenge for the US to regulate HFCs because of limited authority. And the real change here is that now EPA has ample authority to regulate in 3 areas, each of which I'm going to go into a little bit more detail on. And it's good to note that the Clean Air Act, which is in place before the AIM Act, still remains there, and those existing programs are still around. But this is supplemental to that. Meanwhile, states continue to be extremely important to raising the bar for federal action. And California, Washington, and New York are places to keep an eye on in terms of US states that are actually putting forth tangible policy proposals in this area. So the first part of the AIM Act to understand is the Allowance Program, quite similar to the EU FGas regulation, but with a few key differences. And the AIM Act is consistent with the Kigali Amendment schedule. It puts a very strong emphasis on the enforcement of the allowance system this far. And that includes kind of a real-time tracking and traceability program involving a QR code on every cylinder that will be scanned at the point of entry onto the market, as well as each subsequent point of sale. This really allows for a high level of transparency and verification about allowances, and is an important initiative to prevent illegal trade and actually realize the climate benefits of this new law. We've also seen US EPA have a pretty strong initial enforcement focus in terms of cooperation in the US government with formation of an interagency task force on illegal trade established. And they recently announced their initial enforcement actions that amounted to preventing HFCs in the first few months since it's come into effect of over 500,000 metric tons of CO2 equivalent, quite significant. And it's going to be even more important going forward as we see the incentives for illegal trade continue to grow as the phase down continues. And important to note that this allowance program isn't set in stone. It's been implemented partly already by EPA as it's gone into effect this year with a 10% reduction. But EPA will revisit this allowance program this year in a new rulemaking. And this offers some opportunities to improve the allocation method, close loopholes such as requiring allowances for HFCs and pre-charged equipment imports, and also just lay the groundwork for future acceleration. EPA is authorized to begin considering acceleration of the phase down beginning in 2025. There are some limitations to that, in that the text of the law and the AIM Act says that EPA is explicitly limited to accelerate only by as much as the market itself is actually reducing consumption. So this makes the other two parts of the AIM Act extremely critical levers to enable this. So I'm going to talk a bit more about those. So the technology transitions, as it's called, is essentially parallel to the GWP limits, or the placing on the market prohibitions that we had under the EU FGas regulation. Perhaps a little bit more broad in terms of the authority it gives. It essentially allows EPA to restrict, as it says, fully, partially, or on a graduated schedule, the use of HFCs in a certain sector or subsector. Now, we at EIA, as well as others, such as states, have petitioned EPA to replicate the recently finalized California regulations in terms of GWP limits, as shown here. And we have a pending initial rule expected in the coming months to respond to our petition and others. We very much hope to see, an ambitious path forward here, and this will continue to allow for petitions to support more aggressive timelines for phasing out the use of HFCs, not just in new equipment, but it can also apply to servicing of existing equipment in the future. So more petitions to come. And it's important to note, as Finn said, industry counts, and it's not just civil society that can submit petitions to EPA. They're open to industry, as well as any individual can submit a petition to EPA. And third, and I think perhaps one of the more exciting parts of the AIM Act, is the management of regulated substances. This really gives extremely broad authority to EPA to both maximize reclamation of refrigerants as well as minimize releases. And this is where we see potentially the greatest climate benefits in the near term, and the greatest opportunity to accelerate the phase down. Essentially, if we can recover more of these HFCs at their end of life and be reclaiming and reusing those instead of producing more of them, we can really both help support the market in this initial phase down step, and accelerate the rate at which we can stop producing new HFCs. We have estimated that the benefits in the US alone are up to 10 gigatons CO2e by the end of this century. And these are in addition to the benefits of the phase down itself. So these are additional emission reductions beyond the Kigali Amendment to schedule, essentially. And you can see here, right, in this graph on the right-hand side, the quantity of HFCs that are available for us to be recovering from equipment at the end of life is really increasing rapidly in the next 5 to 10 years. So this is the opportunity in front of us, is to scale up the recovery and reclamation in lockstep with that availability of that installed base of equipment reaching its end of life. There are also a few opportunities outside of the AIM Act that I want to cover. I've already mentioned states being an important part of this already, but there is existing legislation, in fact, proposed just in the last 2 weeks in California, SB 1206, that we are actively involved in supporting. And in fact, if passed, this legislation could set that state on a road towards eliminating HFCs entirely by the year 2035. So something to watch out for and support in any way. The other opportunity I want to talk about is really the need for us to think about how we can mainstream this idea of HFC-free technologies into the broader discussion around electrification. This is a particularly important opportunity in the US, given all the funding and resources available for utility programs. It presents, a lot of opportunity to support both new technologies and local implementation of incentives. I think there's overall a real lack of awareness among policy experts in this space on the refrigerant issue, and a lot of work to be done there to kind of help integrate this into those policies. Third, of course, we heard from Asbjorn the long road and work that's been put into changing the IEC safety standards, and it will be absolutely pivotal that the US harmonize with those IEC safety standards that he's working so hard to update. And this will not be an easy path, but a really important one and worth working on. We hope to see, a coordinated effort to put in proposals to update the UL standard in the next year or so. So anyone interested in that, you can please follow up with us. And then last, I want to point out that voluntary programs in the US have had quite a bit of success and is something we should be looking at to replicate. The EPA Green Chill Partnership, for example, has been able to get about a third of US supermarket stores to adopt better practices in life cycle refrigerant management, showing that leak rates can be reduced by well over 50% with just basic improvements. So we should think about this model and how we can apply it to other sectors and also other aspects of this issue beyond leaks, such as to the reclaim and recovery aspect. And that is it for me. So thank you very much for listening and look forward to questions and discussions. Back to you, Claire.
Thanks very much, Christina. We have just a few minutes for questions. We mustn't go over because I think we'll be just cut off. So I think might be a couple of questions in the Q&A. There's one here in the chat that's saying, what do you think about the FGas tax policies in some EU countries, Denmark, Spain, and France, and how they interfere with the FGas regulation? Are tax policies more effective? I think tax policies are effective and have been very effective. I think Denmark is a very clear case in point. I mean, our preference at the last review of the FGas regulation many years ago, 10 years ago, we were discussing it, would be and still is to have a quota allocation fee or auction to really set that price on HFCs. But I think tax policies can be useful in addition, and they have clearly been needed because we didn't have a quota allocation under the last review. So hopefully we will have that. We will have that policy in this new legislative proposal that's expected next week, and that may, and then you can do an assessment of HFC prices in those countries and see if those tax policies can be changed in any way. I'm going to go to the Q&A. There's a question here for Christina. Thanks for the very exciting presentation. Could you please provide more insights on the EPA position regarding allowances for pre-charged equipment?
Yeah, so I touched on this a little bit, but perhaps didn't go into a lot of detail. The initial rulemaking that was finalized has not included pre-charged equipment as requiring allowances. So at the moment, there is no coverage. They have indicated or signaled some openness to revisiting this in the coming revision of that allowance system. I think that's going to be incredibly important. It's a big loophole. You could essentially see, HFCs being produced in the US, exported, and then re-imported again in equipment and not covered under our consumption allowances. So I think that it's really pivotal to bring it into the allowance system, and I think that that's a likely outcome of the next rulemaking we hope to see.
I could have a go at answering Hakan Ildiri's question. I'm not sure if I've fully understood it. I think I don't know if it's possible for Hakan to actually speak. Is that possible for them to verbally ask it, or because I think Hakan is saying that there are challenges associated with using natural refrigerants, and that the refrigeration industry is quite comfortable with using synthetic refrigerants. I think that's my understanding of the question. I guess, so the answer is yes, there are challenges, but also I think we do the refrigeration sector a disservice to say that they would not be able to handle natural refrigerants. Yes, you know, we do have different limitations, flammability and pressure concerns, but it's about investing in our sector and also giving them clear guidance as to, you know, in terms of including natural refrigerants in certification schemes. But also we've seen evidence through, for example, the commercial refrigeration sector, where I began working on this about 13 years ago, and we heard about how difficult it would be for this sector to go over to carbon dioxide, and how difficult it would be for the engineers to produce the equipment and service the equipment. But we've actually seen that the reality is that this sector is much more capable than we sometimes give credit for. So I think, you know, we need to invest in the sector and have hope and, you know, trust in the sector that they can do it with the right guidance. I think the future-proof aspect of what I was trying to say is that HFOs do lead to, some HFOs do lead to considerable breakdown products, which belong to a group of chemicals called PFAS. And it's not just in this sector, across the board of where these chemicals are being used, we're seeing increasing amounts of concern. These chemicals are accumulating in our blood, they're accumulating in our beer supply. You know, there is a lot of public concern over these chemicals. And because of that, I think we are going to see regulation on these chemicals. So that's kind of why I'm saying they're not future-proof. I hope I've answered your question, Hakan. If not, please do send some more information.
Thanks, Finn. There is one other question, which it says consistency on the FGas regulation. It's just moved, sorry. I think it might have just been answered, so it's just disappeared.
Oh, sorry. I think I gave a partial answer on the specific refrigerants that were being
right, I've
mentioned. But you might have an additional input on. It was a question on on these drop-in refrigerants with mixtures of traditional HFCs and HFOs. And my reply is just focusing on the technical side. Right now, manufacturers are using these because they are forced out of 4.4a, and it does give them a lower GWP. But Finn, you previously mentioned that these drop-in refrigerants actually also open up for the risk that servicing will be with illegally imported 4.4a. Is there anything more we should mention there, or you'd like to add?
I mean, I would just add that the thing is as well that these drop-in refrigerants, they do not have a low GWP. They have a lower GWP, which is only low compared to an incredibly high GWP of over 2,000, so or more, or many, or even 4,000. So, you know, what is low now? Low is really below 10 or something like that. That's low. 150 isn't really low when you think about the amount of equipment that we're increasingly putting on the market. So I think we really need to go as low as possible. And although there's room for maybe some of these drop-ins and also for reclaimed refrigerants, but we have to speed up the transition. And I just we're running out of time, or we have run out of time now. So the presentations will be shared by ATMO, I think, through a link, and we'll make sure that our emails addresses are on those presentations. So please don't hesitate to follow up by email. I'd like to thank you all for joining us today. Thanks very much to all the presenters, and enjoy the rest of the conference. Thank you.
Thanks.
Thank you.